Welcome, aloha. Thank you for joining on time. We're gonna wait again a couple more minutes for people to trickle into the Zoom room. And while we wait, we'd love to hear where you're joining from. So far we have folks joining from Manoa, from Maui. Let us know where you're joining Zoom from. Folks coming from Hilo. Okay, other logistical things while we wait, which I can see everyone has already done this, but we really appreciate if the audience can keep their microphones muted. That helps us to hear our Sea Grant graduate fellows or PICAST graduate scholars more clearly as they present their research results to us. It's great to see all these different places in the chat. So we have folks joining from Manoa, from Maui, from Hilo, from Kahalu'u, lots of different places. Okay, and the audience should have the capability to rename themselves in the chat. And you know what I think happened is when I sent the reminder email, the link must have been unique to me. So I see multiple Mayas. So maybe if you came in as a Maya and you want to change your name, you the way you do that is you click the participant list, and if you hover above the one that says me, there should be a more tab, and then you can rename yourself. All right, fantastic. We're going to go ahead and get started. We have a great set of talks today. Thank you so much for joining us. If you're here for Science by the Sea, hosted by Hawaii Sea Grant, you are in the right place. In the months of November and December, we're featuring our Sea Grant graduate fellows and our PICAST graduate scholars. These are graduate students who are conducting research on oceans and coasts. And in addition to conducting this cutting edge research, they also receive training from Hawaii Sea Grant in science communication, and they receive workshops to develop other professional skills. So today we're going to have 3 talks. The first talk is going to be from Shayla, Waiki, and Crispin, Nakoa. Their talk is titled Identifying Sewage Hotspots Along the Hilo Coastline. Our second talk is from a researcher from the economics department. His name is Marcus Peng. His talk is titled What's a Beach Day Worth? Economic Valuation of Waikīkī Beach. And our third talk today is going to be from Nic Vanderzyl. His talk is titled 4,000 Meters Under the Sea, Life on an Oceanographic Research Cruise. Okay, I'm going to enable the live transcription for the meeting. So you'll see that along the bottom of your screen. Some logistics before we jump into the talks. Our format is going to be, we will take a question in between each of the talks, and you can enter those questions into the chat as we go along. So feel free to enter questions as they bubble up and they come up in your mind. And we'll have some time reserved after the 3 talks to have a little bit of a longer Q&A session with the audience. So we're really excited that you're here. We hope that you have questions for speakers who are going to share some of their preliminary research results with you today. The other announcement is we are recording the seminar today. There are a couple people who couldn't make it in real time. So we will be posting the recording to YouTube. So folks who wanted to see our speakers share can revisit the recording on their own. I think that's it for me. Logistics wise, we're so appreciative and grateful for our Sea Grant graduate fellows or PICAST graduate scholars who are going to share what they've learned with us. And I'm going to hand it over to Shayla and Crispin now. Okay, fantastic. We can see your slides.
All right, aloha everyone. Mahalo for attending today's talks. Shayla and I will be kicking it off, presenting our recent work as Sea Grant graduate fellows that we carried out through the University of Hawaii at Hilo's Tropical Conservation Biology and Environmental Science graduate program. We're grateful to be able to share some of our work and explain some of the motivations that drive our passion to protect the environment. Sewage pollution is a threat to coastal communities and nearshore waters. Some of the potential sources of sewage pollution are cesspools, municipal wastewater effluent, and malfunctioning wastewater treatment infrastructure. When sewage reaches the nearshore waters, it inputs pathogens, heavy metals, toxins, and excess nutrients into the system. There are many environmental impacts of sewage that can range from small algal blooms to changes in reef dynamics, or even complete dead zones in some cases. Aside from the many negative impacts sewage pollution has on the environment, it also presents a serious risk to human health. Worldwide, it's estimated that there are millions of cases of gastrointestinal illness, respiratory illness, and skin infections each year that are associated with swimming in sewage-contaminated waters. Here in Hawaii, there's a strong connection to the ocean that can be observed in the common daily activities. Things like surfing, swimming, fishing, canoe paddling, snorkeling, and just spending time near the ocean are all things that are done to fulfill recreational, cultural, and sustenance needs of the people here. The tourism industry is also highly driven by the great environmental conditions present in Hawaii. Cultural traditions and family practices have been passed down through generations, and many of them also rely on the availability of clean and safe waters. It's important to understand the water quality here, not only because there's a deep connection to the ocean, or because the economy heavily relies on it, but also to perpetuate the traditions and culture that have existed in Hawaii for over 1,000 years. My motivation for protecting environmental quality is driven by many things. Being born and raised in Hawaii, I have a strong connection to all of the resources that the ocean can provide. I grew up surfing, fishing, and swimming up and down the Hilo and Keaukaha coastlines. When I was younger, I was able to travel to new places for surfing competitions, which is something I could have never done if I didn't have the opportunity to practice almost year-round at my home break, Honolulu. Fishing was a way to bond with my dad and friends and share something that we all love to do. The best part of fishing to me is being able to have the freshest fish possible for dinner and sharing it with those who have helped me. Thinking about it now, most of my free time was spent playing in the water, and it didn't really matter what I was doing. As long as I was near the ocean, I was happy, and I couldn't imagine growing up any other way. Even today, my preferred stress relief method is squeezing in a quick surf session into my busy schedule as a graduate student. I'm also still able to provide many meals for my family and friends through fishing. My passion for protecting the environment, especially the ocean, stems from all these experiences that I had growing up. I feel that if I can continue to help the environment, then the environment will continue to help me and others into the future. My long-term goal is to preserve and improve the quality of the environment so that future generations can at least have the same opportunities that I was given. Today, I feel really fortunate to be able to answer some of the questions I've wondered about the water quality of my home for most of my life.
Like Crispin, I too was born and raised on the island of Hawaii. I grew up in Puna, but majority of my family live in Keaukaha, the area where I'm lucky enough to conduct my research as a Sea Grant Fellow. I was raised by a family of fishermen, divers, and opi'i pickers, and all of my best memories are from these experiences, tagging along with my dad and others as they went fishing or diving. As a family, we spent ample amount of time in or near the ocean. Almost all of our family gatherings consisted of us spending our days at our favorite beaches till the sunset. During the summers, while school was out and my parents were working, I often was dropped off with family in Keaukaha. Even then too, we ended up at the beach. The summers were for camping at Puhi Bay, and I got a chance to spend time with aunties, uncles, and cousins, and just really enjoy the summer days in the cold, fresh water of Puhi. Throughout my childhood and into adulthood, the ocean has always been my go-to. Although nowadays, I don't have much time to spend at the beach like I would like to, these waters always keep me rooted. My connection with the ocean from my upbringing has led to this sense of kuleana or responsibility to take care of what is taking care of us, and has ultimately led me down this road of conserving our natural resources to ensure that the future generations get to experience it in the ways that I have.
My master's thesis work took place over 15 months, beginning in July 2020 and finally concluding last month in October 2021. I selected 20 sampling stations that included every beach park in the Hilo area and other areas of cultural significance. 5 of my stations were also monitored by the Hawaii Department of Health during this time period. All of these places are stations where I grew up surfing, fishing, or swimming, and oftentimes a combination of all three. Researching the water quality here allows me to satisfy my curiosity of these areas. The two main goals of my work were to assess the nearshore waters of Hilo for the presence of sewage and to identify if any sewage pollution hotspots existed. Current monitoring of nearshore waters relies on the use of only one fecal indicator bacteria, or FIB, that is widely used throughout the world. This FIB is also known to be highly variable in tropical settings, guiding me to include other sewage indicators to assess the presence of sewage at these stations in Hilo. At each station, I collected water samples and analyzed them for 3 FIB, nutrients, and stable isotopes of nitrogen and limu. These sewage indicators have all been used in previous studies to assess sewage pollution, but they're rarely used in combination by monitoring agencies. The results for 2 of my FIB measurements were somewhat contradictory, and the results of my 3rd FIB aren't available yet. Many stations exceeded the standard for enterococci, the FIB monitored by the state, and all stations were well below the standard for Clostridium perfringens. Nutrient levels were also variable, with some exceeding standards and others falling below them. The nitrogen isotopes in limu indicated the presence of some sewage in certain areas, but no levels were very high, and it didn't indicate any sewage in other areas. Measurements of these indicators also varied from month to month within sampling stations. All of these sewage indicator measurements were considered by using a sewage pollution scoring tool. This tool assigns weights to each indicator and ranks them based on their relationships to their respective standards. The outcome is an easy-to-interpret score that can be compared among stations. Sewage pollution scores of my stations range from 12 to 14, and all stations fell within the cutoff for the low-impacted sewage pollution category at 17. This can be seen on the graph as a gray line. This allows me to conclude that the nearshore waters of Hilo are impacted by some low-level sewage pollution, but it's important to note that there are times when sewage pollution could pose a greater risk to human health. Now I'll turn it back to Shayla to let you know what she's learned through her portion of the project.
As Crispin reveals the broader picture of what is happening in the coastal waters of Hilo in regards to sewage pollution, I reveal the nitty-gritties of it. In the state of Hawaii, many homes still utilize cesspools as a means of disposal for household waste. With the porous substrate of the Hawaiian Islands, this allows for seepage of sewage contaminants into the groundwater. This then brings us to the first aspect of my thesis project, and this question here. Is sewage from homes reaching our shorelines? In order to figure that out, we use dye tracer tests that consist of adding an organic dye into a cesspool of a home and then monitoring the shoreline for its presence. This past summer, we've completed a total of 4 dye tracers, each telling us that sewage is in fact reaching the shoreline. Within Keaukaha and Hilo as a greater whole, not only the use of cesspools are threatening the quality of coastal waters. In addition, the outfall pipe from the Hilo wastewater treatment plant is located in Keaukaha and spans approximately 1 mile offshore of Puhi Bay. This has been a concern of the Keaukaha community since its first installation. The other aspect of my thesis research focuses on collecting samples from the end of this outfall pipe to see if its FIB levels are high and therefore contributing to sewage pollution in the area. In order to do so, the outfall pipe must be accessed via boat and water samples are collected using a Niskin bottle, which is basically a fancy word for a bottle that collects water samples beneath the surface. These samples are then measured for FIBs, Enterococcus, and Clostridium perfringens, the same ones that Crispin mentioned previously. The 1.5-year span of our project has taught us quite a few things about the shorelines we grew up playing in as a child. First and foremost, 4 out of 4 dye tracer tests has indicated that sewage from homes are in fact reaching the shorelines. In our research, we have found that it takes approximately 20 hours to 3 days for the dye to be present at the shoreline, which is all dependent on the distance of the location from the shore. We have found that groundwater carrying these sewage contaminants from cesspools to the shoreline is moving approximately 125 yards per day. Just imagine, it is moving about the length of a football field, including the end zones, in 1 single day. On the other side of things, the outfall pipe sampling have revealed rather low levels of FIB, and sewage pollution scores at our shoreline stations were also low. It is unclear why this may be the case, but dilution may be a factor. It never occurred to us as kids that the waters we played in could be threatened by sewage pollution. But as we grew up, the question of water quality in Hilo always lingered. We just never knew the answers. Upon entering into our graduate work, we are able to uncover the answers to the question many wondered about. We are glad that we are able to figure out the problems of water quality in our home because after all, these are the waters and the ocean that has shaped who we are today. Upon completion of our theses, our compiled data will be shared with state agencies like the Hawaii Department of Health and hopefully aid in decision-making processes that will address the issue of sewage pollution in coastal waters of Hawaii. In addition, the findings of our study will be shared with the community so that they are informed of the conditions of the waters they frequently visit and the resources they heavily depend on. The solutions to this ongoing issue is far from clear. And although we have spent the entirety of our graduate career identifying the issues, unfortunately, we do not have the answers when it comes to identifying a solution. Through our work, we are providing data that show the current conditions of water quality in Hilo and could serve as a baseline for future comparisons. We do hope, though, that these issues are addressed. From the kids playing in the Hilo waters to the graduate students conducting research in the same areas we grew up, we hope that the children of the next generations will be able to experience a childhood similar to ours. Mahalo nui to you folks for your time today. We can take any questions the audience may have.
A round of applause for Shayla and Crispin. What I'm going to do is ask the audience to send their questions via the chat. And while we take a question from the audience, we will get Marcus's slides up. Oh, excellent. Okay, so there are two questions from the audience. We'll take Yoko's, and then we might ask Rachel to save hers for the Q&A at the end. Yoko, do you want to unmute your mic and ask your question out loud?
Yeah, gladly. Thank you both for this awesome presentation. Really fantastic job on a very crucial topic. I wanted to say or ask you if money was not an issue. If all homeowners could afford whatever system you wanted, if the county, state could afford whatever you wanted, would that change your approach regarding solution? And what would be a solution that you could think of?
I can answer this. You can go first, Shayla.
I just was thinking if money wasn't an issue, I think definitely upgrading the sewage treatment plant on Hawaii Island in Hilo would be like a main concern or a main focus. This one you can go now.
Yeah, I can just add on to that a little bit. It would also be not only the sewage treatment plant, but creating the infrastructure throughout the majority of Hilo at least. Because right now it's only serving a very small portion and the facility is also in need of upgrades. So just overall, the wastewater management system in Hilo needs to see some type of help.
Thank you both.
Excellent. Thank you, Shayla and Crispin. There are a couple questions for you in the chat, which you can feel free to address in your free time. We're going to move to our next speaker, Marcus. So Marcus, if you want to bring up your slides, that would be great. Excellent. And we can see your slides now. You can go ahead and start whenever you're ready.
Aloha, Marcus Peng, and I am working on a project looking into the value of Waikīkī Beach, something we may all be a little bit familiar with. A little background I wanted to provide, which is previously we did some work in this area looking at the economic impact of what would happen if the entire beach were to erode away, where we took an old report and we updated what they were doing with their data, with new data and their methods. And we found that some 58% of visitors could disappear because of erosion. And that on average, visitor spending was around $333 outside of hotels. And of course, these are economic transactions, right? So these are transactions that make up only a portion of the value of Waikīkī Beach, because there's a very large benefit that we get from the beach, whether that's for recreation, whether that's for cultural purposes, or whether that's aesthetics and things like that, that are not reflected in these prices. So what we would like is a more complete understanding of the economic value of the beach to help inform some of the decision making that goes on in beach management. Okay, there we go. Okay, so the beach, of course, as you may have heard or have seen, is slowly eroding. In many places, the beach naturally moves back and forth, but when the back, in this case, the back of the beach is right up against a built environment, so there's nowhere for the beach to go naturally. And this is an issue, of course, because it's an artificial beach. Waikiki erodes more so than other shorelines on Oahu. Nourishment, that is, some sand is dredged up and put back on the beach, as we have seen recently, over the years has maintained the current width, of course, so it never gets too narrow. And, oh, okay, you may have seen this headline a few days ago in the Star Advertiser. So, this is right in front of the Outrigger Reef, actually. So it goes to show, how much of this is going on. Okay. And let's see here, we have some research questions. So what we wanted to ask was, the value of Waikiki Beach is obviously considered very large, but specifically, what do beachgoers prefer and what are their perceptions of the beach itself? And we wanted to look into the dollar values, okay, that people hold for the beach and its amenities. Does the value of the beach then justify management actions such as nourishment by bringing in more sand? And we address these questions through an on-site survey with beachgoers that involve what's called a choice experiment. So let me just briefly illustrate what we've been doing. So imagine for a moment there's a beach and there are many characteristics. Maybe the beach is this wide, maybe you can see this far underwater, maybe there is some price, okay, maybe it takes you some time and effort to get there. And we want to think about the values for all these different components, right? And then added together, of course, is the value of the beach overall. And we can separate these components also statistically through different methods. So our survey looks something like this, right? People are asked the question where they're asked to judge the current beach against some hypothetical changes where something about the beach has changed or is different, okay? And through statistical methods, we're able to evaluate what these differences are and how much people value these differences. So where we conducted this study was it was along different segments of Waikiki, as we can see here. So here we have, the Hilton Hawaiian Village on one end, and then Kaimana Beach is on the other. And we had surveyors go throughout this area. Actually, here we go. This is a specific map of where the surveys themselves were taken. So it was, there's a nice distribution, right, all across Waikiki. And for our in-person survey, so we had surveyors, including myself, where we walked around on the beach and we talked to people by just going up to them and giving them, an iPad with the survey and asked them to take a little bit of time from their day and fill out the survey, which was about what they thought of the beach, what they thought about changes to the beach, what they thought about, how the beach could be improved, and so on. Okay, so from our results, we can see that the vast majority of the respondents who filled out the survey were visitors. Okay. And these visitors are fairly similar to what we expect from the visitor arrivals that we have every year from the Hawaii Tourism Authority. So the survey itself was conducted from November 2019 to January 2020 on all different segments. And we had just slightly under 400 respondents. And we collected a great deal of information with timestamps, geolocation, and then we could control for things like weather, socioeconomic factors. And when I say control, I mean, we statistically control that in the estimate. Okay. And we can see that most people it was not their first time. Quite a few people, it was their first time, but most people have been to Waikiki before. We have some education background, we have some income levels, some age, and the weather conditions that they were interviewed in, different days of the week, where people were staying if they were a visitor, and what parts of Waikiki they were interviewed at. And we have some perceptions that we got from our respondents. And so we asked people to rate several characteristics of the beach out of 5 stars, like you might in a hotel review or in a Yelp rating. So these are the mean scores, okay? So what people rated as the highest was the ease of access, beach access, and then what people rated the lowest were the public bathroom facilities that were on the beach. So using a statistical model, we were able to determine that overall, beachgoers were willing to pay around $6.56 more for each foot of a wider beach. Now, this is not a linear, so this is not a straight line, right? This is sort of a curve, actually. And if the beach was wider, they were willing to pay less. But if the beach was very narrow, they were willing to pay more, which is very intuitive, right? Because you would like some amount of beach. And what's important is that we also determined that people are willing to pay for the beach, yes, but only to an extent. In this case, up to around 218 feet of beach width. Okay. And likewise, people were concerned with water quality if they were able to see underwater. So people were willing to pay an extra $14.66 for an extra foot of underwater visibility. So this is a linear relationship. This is a straight line, right? And the beach trips, as it is worth about $339 per trip per person. People who do not support beach nourishment, people who do not support letting the beach erode, and visitors especially value the beach as it is. So now that we have some dollar amounts, we can attempt to aggregate this result, okay? And first of all, we would need to know, of course, how many people visit the beach. And we can do this, we could get an upper bound and lower bound estimate by looking at things like lifeguard statistics and also hotel occupancy, okay? So as a lower bound, Waikiki has at least 4.6 million visitors, okay? As an upper bound has around 10.3 if we go by the lifeguard statistics. Although the caution here is that lifeguard counts of how many people are on the beach is generally considered to be a bit of an overestimate, right? So this is why this range is useful to think about. So if we aggregate the result, okay, the beach is worth about, a 3-foot expansion of the beach is worth about 65 million to 130 million. Okay, and then the beach itself, as it is worth about $2 to $4 billion. So this is, for the entire beach as it is. And it's useful to think about our findings in context, right? Because of course, the government is allocating resources to maintain the beach in association with, with local businesses. And if we compare what we found in this study, even to our previous estimate, which is $2.2 billion, right? We can see that the investments that government is making in maintaining the beach is well justified because the benefits are so much larger, orders of magnitude larger, in fact. So what I would say is that, either estimate that we have found, well justifies the investment in renourishing Waikīkī Beach. There's a substantial willingness to pay for the beach as it is. People like the beach as it is a lot, okay? Recreationists, people who go to the beach, would like wider beaches, but only to some extent. You don't want a beach, you know, that's as wide as possible. And beach nourishment is well justified given the very large cost-benefit ratio that we can see here. By the same token, nearshore water turbidity management is also justified. People would like clear water, people like clean water, right? So there are many things that we could do on land to control land-based pollution. And if we come back, there is a substantial value for the beach as it is. So people really like the way it is. And of course, we are obviously not suggesting that you know, people be charged to go to the beach. This is simply a useful exercise in understanding you know, how people look at these values and how they incur them. And we would like to acknowledge our funders, including the Waikīkī Beach Special Improvement District Association, and also the University of Hawaii Sea Grant, and also our hardworking surveyors who came out with us, you know, in the hot sun and walked around and talked to many people every other day. So thank you for your time. And if you have any questions, please feel free to contact any of the authors, including myself.
Applause for Marcus. Thank you so much for your talk. Let's get questions from the audience, from the chat. I already see questions coming in. Anita, would you like to unmute your microphone and ask your question out loud?
Hi, sure. Hey, Marcus, that was really interesting. I was just wondering, so I thought it was really cool that you also asked for socioeconomic backgrounds of your interviewees as well. I was wondering if any like interesting patterns or like, I don't know, just something you like noticed was interesting based on like if you were to look at certain groups' responses. Like for instance, I'm thinking, I don't know, maybe like visitors from China are very happy and pleased with the beach as it is right now, while like if visitors from, I don't know, another tropical island or who's from Hawaii, like realize that this is not a good condition and they're the ones that are requesting, you know, like wider beach space or whatever. Like just curious to see if you noticed anything interesting.
We actually did run something on this, okay? So this is, so because we had the socioeconomic background and then we did a lot of interaction testing of all the possible variables that were there. Now, for most of it actually had no effect at all. Okay, so for example, you know, the weather had no effect on people. The day of the week that they were interviewed had no effect on people, but there were some that were significant. So the ones that did make a difference was specifically people that were, come back for a moment. So visitors, okay, visitors really like the beach as it is. So they, and also people who, so there were people who supported renourishment, and then there were people who supported, actually, sorry, let me step back for a moment. We shouldn't say that renourishment is changing the beach, actually, because the, you know, as we know, because the beach is eroding, renourishment to some extent, so some renourishment is in fact keeping the beach as it is, right? So when there's no renourishment, the beach disappears. So we found that people wanted to keep the beach as it is, and that implies they support some renourishment to some extent, okay? And then to answer your question about different people from different places, what they thought about different characteristics, we found that Japanese tourists were especially in favor of beach improvements. That is, to either make the beach wider or make the water clearer, as opposed to other tourists from other places, either here in the US or elsewhere, which is Canada mostly. They were mostly concerned with just keeping the beach as it is. So a lot of people are fixated on the notion that Waikiki should look a particular way, and they like it that way. If that answers your question.
Thanks, Marcus, for that answer to the question. I see there are other questions in the chat, and we will have time at the end of the seminar to dip back into our pool of questions. What we're going to do now is we're going to bring Nic Vanderzyl up to the Zoom stage. And I need to add Nic's spotlight. I'm going to remove Marcus's. Okay. Nic, when you're ready, you can bring up your slide deck. Thank you, audience, for all your questions. Keep them coming in the chat. And Marcus, if you'd like to answer questions via the chat, you're more than welcome to. Nic, we're not seeing slides yet, but maybe you're still bringing them up.
Sorry, my screen just went like completely blue, so I'm having to figure out what's going on.
Okay, no worries. How about we'll take another question from the audience for Marcus while we figure, oh, maybe this is it.
Yep, this is it.
Okay.
Did it just go blue?
It did just go blue. That's really interesting. So what we'll do is let's take a second question from the audience for Marcus, and then we'll let you kind of troubleshoot that. So I'm gonna bring Marcus back. Okay, Marcus, I see the next question down is from Ellie. Ellie, would you like to unmute your microphone and ask your question out loud?
Yeah, I was just looking for some clarification on one of your aggregate results. I was wondering if the 3-foot expansion that you said was valued from $65 million to $130 million was on top of the beach as it's, valued as is from 2 to 4 billion.
Thank you for the question. So the way to think about these dollar amounts is that you shouldn't think about, well, in this specific case, okay, because of the way we estimated the value for the beach as is, we shouldn't think about it additively, with the expansion value, right? That's also here. So we should think about that value for the beach as is, applying only to the beach as is in this current state, right? And then the 3-foot expansion, the value for that is specifically for if the beach were to be wider. But it's important to note that what we found was that people have a certain attachment to the beach as is. Does that answer your question there?
Yeah, that does. Really quick. So the 3-foot expansion is worth 65 million. It's not talking about the beach. If it were 3 feet wider, what it would be valued at.
Right. It's only a increase, right, in benefits, right? So that 65 to 130 million, that is strictly speaking the difference in how much better off people are, right, from the beach expansion.
Okay, got it. Thank you.
Thank you.
Mahalo, Marcus. Nic, we do see your slides now. So we're going to hand the microphone back to Nic. And whenever you're ready, you can begin your talk.
Alrighty. Hello, everybody. My name is Nic Vanderzile. I'm also a Sea Grant Fellow. My current research is actually, I'm a collaborator with Crispin and Shayla working on sewage pollution, but I thought that since they just discussed, gave a great presentation on sewage pollution, that maybe I would talk about something a little bit different. I just got back from 45 days at sea, so I thought that would be a great opportunity to kind of share with everybody what life is like on a research cruise. So this research cruise is a consequence of society's increasing need for rare earth metals as we seek an environmentally friendly and sustainable future. Rare earth metals such as copper, cadmium, and cobalt are currently mined around the world with environmental and human rights impacts. Cobalt, a major component of car batteries, has been linked to child labor violations in countries such as the Democratic Republic of Congo, while cadmium mining has been linked to the poisoning of rivers and lakes, leading to increased rates of cancer in communities surrounding these areas. It has been known for decades that these minerals can be found across the seafloor, and deep sea mining is becoming an increasingly popular due to its reduction in human health impacts. But before it can be conducted on an industrial scale, the International Seabed Authority has required that environmental impact studies must be conducted to better understand how this will impact the deep sea, which is the largest part of the Earth's biosphere. Unlike in history's past, this is the first time as a society we will be able to make an informed decision as we begin to extract minerals from our planet. So deep sea mining will basically be looking at 3 different areas. There are the abyssal plains, and we will be mining for polymetallic nodules. Polymetallic nodules are basically this kind of globular circular rock, and they have rare earth minerals such as iron, manganese, nickel, cobalt, copper, and titanium. We'll also be looking at mining extinct hydrothermal vents. So these are hydrothermal vents that no longer have these hot water plumes coming out of them. And these are really rich in sulfides. And then also we are looking at mining seamounts, which are essentially underwater sea mountains. And they are rich in a rare earth metal cadmium. And as oceanographers, we have a deep concern of the potential impacts deep sea mining will have upon communities both on the seafloor and the water column. This graph that was in a recent publication gives a great example of the deep sea mining operation. So essentially they are planning on having robots on the deep sea floor, mining abyssal plains, seamounts, and mid-ocean ridges. And it is connected to this pipe that will send these rare earth metals to the surface, where a ship will then separate the rare earth metals from the sediment. And then the sediment will be reintroduced into the water column at about 1,000 meters. And understandably, this can have a variety of impacts on the entire food web, ranging from microbes to megafauna such as whales. For example, I'm just going to go off a few. There's more on the bottom if you want to give them all a quick read. This mining operation is going to be very loud, and this is how it will disturb how cetaceans such as whales and dolphins are able to communicate with one another. Also, introducing these fine particles of these rare earth metals are toxic. So this has actually unknown consequences on microbiota such as bacteria and zooplankton. And then more on an individual scale, right? You're going to have these plumes that are going to be getting in fish gills, so you can have respiratory distress, reduced feeding. Also, in the deep sea, there is no sunlight, so these animals can communicate with one another via bioluminescence. And if you have this water plume that is full of fine sediment, there's going to be a reduced communication between organisms, which can in return impact reproduction. So we went to the Clarion Clipperton zone, which is essentially, this is on the bottom right-hand side, right-hand side. It is in between Hawaii and San Diego at about 10 degrees latitude. We went on the boat, the Maersk Launcher, which is being subcontracted out by the metals company. It's about a 90-meter vessel, so that's about 300 feet roughly, maybe a little bit more for people on imperial scale. It is a Danish ship, so that was interesting. There was no pictures of the president on the ship. There was a picture of the king and queen. I've spent a total of 43 days at sea. And once again, the overall goal of this study was to just perform baseline biological surveys. So essentially, we just needed to know what was out there. This has really never been done before. So starting off with life on a ship, because this is not an actual research vessel, this vessel is actually previously used for the oil industry, and it has been refitted for science exploration. But since it is through a oil industry company, we were required to wear full PPE, so personal protective equipment. So that involved this lovely jumpsuit right here, as well as steel toe boots and hard hats. You wouldn't think that this would matter that much, but once again, we were at 10 degrees, and to put into 10 degrees latitude and to put into perspective, here in Hawaii, we're at 19. So it was very hot the entire time. And then these are just kind of images across the ship. This is the galley. I will admit it was kind of nice not having to cook for myself for a month and a half. They also did our laundry for us, which was amazing. They do have a ship gym as well, so we could go running instead of being stuck on just a little 300-foot vessel. This is a picture of our stateroom. So this is where we spent any time that we had to sleep, which was kind of intermittent. This chair on the bottom, that's the captain's chair. It's serious. I thought it kind of looked like a spaceship pilot chair. I thought it was very cool looking. It's crazy watching him use these little knobs to, you can see on the armrest, to kind of rotate the vessel. We had some really great sunsets on the ship as well. And then safety meetings 2 times a day. It was wonderful. As far as science operations, we did a whole bunch of different science operations. So starting off with deck operations, on the top left-hand side, this is Gabby, excited to get her benthic boundary layer sampler, we termed Barbarella. And what this does is we essentially tied 300 pounds of iron weight to it and sunk it to the bottom of the ocean. And then what she does is she rests about 5 meters above the seafloor and collects, filters water and collects basically what organisms are sitting there on the benthic boundary layer. So this is important because this is where the mining is going to be taking place. So we need to understand what lives there. We also, on the bottom left-hand side, this is a CTD. So this is a conductivity, temperature, and depth sampling machine. So all of those are little bottles that hold about 15 liters of water. And we send it down to different depths and fire them, and they collect ocean water. And then we bring them back to the surface and are able to get a whole bunch of different measurements: pH, dissolved oxygen, temperature, nutrients, environmental DNA. We also did mock nest tows. A mock nest is essentially a series of nets that open and close that are stacked on top of one another. On the left-hand side, that is the zooplankton net. It's about 1 meter square. And then if you look on the right-hand side, that is the 10-meter net. So that net is huge. You can see the person to the right of it to kind of give you a perspective on how big that net is. And we use these 2 different nets for 2 different reasons. The smaller net is for smaller organisms such as zooplankton, and the bigger net is for larger organisms such as fish. And what we'll do is we'll send it all the way, not all the way, we'll send it a couple thousand meters down to the ocean floor and then open a net. And then we will tow it for X amount of time, close the net, and go up to the next depth, and then do this again and again and again until we get to the surface. And then once we get it to the surface, we have to spray these ginormous nets, which obviously there was a lot of getting sprayed in the face with that. Moving into the lab, we definitely got to see some cool things through the entire process. On the top left-hand picture, this is processing samples for the zooplankton team. And I'm holding in my hand, that is a cow tongue worm. It was huge. It was about the size of 2 of my hands. But there was also a bunch of different operations that were involved in the lab. The top middle picture, we are sampling for eDNA. So this is filtering about 10 liters of water and collecting, E stands for environmental. So it's just environmental DNA that has been sloughed off of animals. And you're able to then take that into a lab and sequence it. And it allows you to find out what organisms live in the area without actually capturing the organism itself. The bottom middle picture, this is the fish team. So once they have their nets done and on the the gray tube that is basically what collects everything that is collected in the net, and then we dump it into a tray, and we have to sort through all of the little organisms that we find. Sometimes, such as shrimp, they look very, very, very similar, so you cannot tell what they are. So you have to use a microscope to kind of look at the different types of legs, or count the number of sections that it has to help you identify what it is. And then once you have sorted, on the bottom right-hand side, you can see a tray where we've sorted through everything. After that, you will count everything and get a weight. I figure most people want to see deep sea, cool deep sea creatures. So this is some highlights of the different things that we saw in the ocean. I like to bring attention to, most people think of anglerfish. That's the fish that has the little light above it to attract its prey. I'm not a deep sea ecologist. I'm more of a coastal person. I didn't know that there's a bunch of different species for these. So on the top left-hand side, that is a female anglerfish, and it is in a plastic spoon to kind of give you an idea of how small it was. But if you look 2 pictures over, that's a different species of anglerfish, and it was ginormous. Dr. Jeffrey Drazen, the gentleman holding the picture, said this may have been one of the biggest anglerfishes he's ever seen. We also found a bunch of different, the hatchet fish is also a very common organism that we found. There's another picture of the cow tongue worm on the bottom right-hand side. Not sure if anybody is familiar with vampire squids, but we also got a couple of those. Very cute. I thought it kind of looked like Dumbo. And then of course, the viper fish. So that is middle right-hand side with the long teeth. This was actually pulled up close to the surface. So this organism is a migrator. So what that means is this organism is a deep sea organism, but at night, there is the world's largest migration, where things from the deep sea come to the surface waters and feed, because this is the highest area of productivity. So this organism was caught near the surface, and therefore it wasn't dragged through the water column for a very long time, maybe like 30 minutes. So it came in such excellent condition. Moving on to zooplankton, the small stuff. This is some of the stuff that we pulled out of our nets. Of course, with these things, you have to look through them with a microscope. And let me tell you, it is incredibly hard to look through a microscope for little organisms like this. Definitely the highlight, I think, was the octopus larvae. And other than that, that was kind of a brief rundown of a deep sea research cruise, and I'm available for any questions.
Thank you, Nic. Applause for your talk. Thank you for sharing. If there's any questions for Nic, if folks could drop them into the chat, that would be great. I'll ask a question as we wait for those questions to come in. Nic, you alluded to not getting much sleep on the research cruise. Is that because there is science that happens at night? And can you tell us more about the kind of research that happens at night versus the daytime?
Right, so there's basically 24 hours of operations. So it's really expensive to go out and do a research cruise. So you try to get the biggest bang for your buck. And we're trying to look at the community structure, both at daytime and nighttime. So essentially for the first 3 days, we would, I was on the zooplankton team, so I did the net tows. So for the first 3 days we got to station, we would do day tows. And then, so let's say we put the water in about 7:30 in the morning, pull it out about 2 in the afternoon, and it takes about 3 hours to process it. And then after that, we got a couple hours of sleep, and then we switched to sampling at night. And that basically put the water, the net in the water about 10 o'clock at night, and then pulled it out about 5 o'clock in the morning, and then processed until about 9 o'clock. So sleep was kind of fleeting at times. It kind of just depended on the operations. Sometimes the Lords would bless us and something would break. And while they fixed it, that gave us a little bit of time to go catch some Z's. But also, I will admit that everybody on the science team was really great working as a community and working as a team. And if you saw the physical exhaustion on somebody, it was very common for somebody to just kind of step in and be like, hey, I am well rested. You look exhausted. You should go catch some sleep and I'll do your job for you today.
Wow, very cool to hear about how teamwork and flexibility and adaptability comes into play on these research cruises. Thank you again, Nic, for your talk. What we'll do now is we're going to bring all the speakers back to the Zoom stage. So I'm going to add some spotlights here. And what we can do is if people have questions for our speakers, we probably have time for one more question before we have to close the seminar today. Feel free to drop those into the chat. We had some really good questions for Shayla and Crispin. And maybe what we'll do is we'll revisit that if I don't see any new questions come up in the chat. Okay, so scrolling back. Oh, there's a new one. Oh, that's a comment from Brad. Well, I'd love to hear the answer to this question. So Rachel asks, what was the temporal spread of coastal sampling? Could pollution levels be different during different conditions? For example, after storms or during drier periods? Shayla and Crispin, do you mind answering that question as our last question for the seminar?
Yeah, sorry, I actually should have, I responded privately, but I should have responded for everybody who might have the same question. But basically, we weren't able to like fully analyze that yet. We do plan on looking at that in the future since we just finished sampling last month. But just based off of my observations, and I'm sure Shayla would agree, it kind of seems like when they're rainier, like when it's a rainier time, then it'll be elevated count for certain bacteria. The nutrients may be a little bit higher, but when you put it all together, it's still kind of lower overall than we've seen in other places, and previous studies have found in other places of Hawaii Island. But yeah, as we continue to get like our full data set back, then we can have a better picture of everything and then start looking at it like on a more of a month-to-month basis to see if like presenting it as an average would actually be masking like some areas that are actually high for half the year, but they're really low the other half of the year, or instances like that. So we do plan on looking into that a lot more.
Fantastic. Shayla, did you want to add anything else to that?
No, not really. Crispin basically nailed it right on the head.
Awesome. So it sounds like we have to come to a future presentation to see all these awesome research results compiled and synthesized. Thank you, audience, for joining us for the Science by the Sea seminar. We're taking a break next week because next Thursday is Thanksgiving, but you can join us again on December 2nd. We have 3 new talks to share on Thursday, December 2nd, again at noon. Thanks so much for joining us, and we'll see you next time.